This is CIE Paper 2 Further Pure Mathematics 2. And this is the most recent paper, October-November 2025, variant 24. In number 6, we need to find the particular solution of the differential equation dy by dx plus 1 plus x over 1 minus 2x minus x squared times y equals to 1. Since here we have an equation of the first order and it is linear, so I think about an integrating factor. What is an integrating factor? An integrating factor is a function that turns the first order linear differential equation into the derivative of a product. Once I have this derivative of a product, I just integrate to find the solution. To use the integrating factor, my equation should be written in standard form. Since the given equation is already written in the form dy by dx plus function of x times y equals g of x, so it's easy to choose my integrating factor. The integrating factor I equals e to the power integral of f of x dx. So I equal e to the power integral 1 plus x over 1 minus 2x minus x squared dx. To solve this integral, we use substitution. Let u equals 1 minus 2x minus x squared, and this is our denominator. The derivative of u du equals minus 2 minus 2x dx. If you look at the numerator, I have 1 plus x and I have dx. So I can replace 1 plus x dx by du over minus 2. So I equal e to the power integral of du over minus 2u. Implies that I equal e to the power of minus half integral du over u. I took the constant out. So I equals e to the power minus half ln u. Replace u by x again, so I get e to the power minus half ln 1 minus 2x minus x squared equals to e to the power ln 1 minus 2x minus x squared all to the power minus half. The exponential and the natural logarithm cancel because they are inverse functions. So I get I equals 1 minus 2x minus x squared all to the power minus half. Or I equals 1 over radical 1 minus 2x minus x squared. And this is my integrating factor. Now I'll multiply the whole equation by I. So I times dy by dx plus I times 1 plus x over 1 minus 2x minus x squared times y equals to I times 1. A common mistake here is to forget to multiply I by the right-hand side. Implies that 1 over radical 1 minus 2x minus x squared times dy by dx plus 1 over radical 1 minus 2x minus x squared times 1 plus x over 1 minus 2x minus x squared times y equals to I. And this is 1 over radical 1 minus 2x minus x squared. Now, look at the left-hand side. This is the derivative of the product of two functions. One of them is 1 over radical 1 minus 2x minus x squared, and the other one is y. If you notice here, the derivative of y is dy by dx, and the derivative of 1 over radical 1 minus 2x minus x squared, it's all this function beside y. So I write derivative with respect to x of 1 over radical 1 minus 2x minus x squared times y equals to 1 over radical 1 minus 2x minus x squared. Now, since I got the derivative of a product, simply I need to integrate both sides to get the solution. The integral and the derivative cancel each other because they are inverse operations. So y over radical 1 minus 2x minus x squared equals integral of 1 over radical minus x squared plus 2x plus 1. To solve this integral, I need to complete the square. So inside the bracket, we are going to add and subtract 1. So I get integral of 1 over radical minus x squared plus 2x plus 1, and this is the perfect square, minus 1 and then plus 1 outside, equals integral of 1 over radical minus x plus 1 squared, so take this out, plus 1 plus 1, equals to integral 1 over radical 2 minus x plus 1 squared. Now I need to match this from list of formula. So from list of formula, I get integral of 1 over radical a squared minus x squared equals sine minus 1 of x over a. To match this with our expressions, notice that 2 can be written as radical 2 squared. So this is a. And this integral is equal to sine minus 1 x plus 1, which is x in the list of formula, x plus 1 over a, which is radical 2. And since it is indefinite integral, I add c. But we need to find c because initial conditions are given. So substituting y equals pi and x equals to 0, I get pi over radical 1 equals sine minus 1 of 1 over radical 2 plus c, implies that pi equals pi over 4 plus c. So c equals 3 pi over 4. Now substitute c back in the equation. I get y over radical 1 minus 2x minus x squared equals sine minus 1 of x plus 1 over radical 2 plus 3 pi over 4. Or isolate y and multiply the whole equation by radical 1 minus 2x minus x squared. So I get this final answer. Let's now distribute the marks. There's an accuracy mark for getting the final answer and accuracy mark for getting the constant c. There's a method mark to substitute the initial conditions. There's an accuracy mark to get this answer for the integral. And there's a method mark to integrate the right-hand side, and the integrand must be of correct form. There's a basic mark to complete the square. And there's a method mark for the correct forms on left-hand side and right-hand side here. There's an accuracy mark for the integrating factor. There's a method mark to integrate using substitution method. And there's an accuracy mark for the ln answer.